Hello, algebra students. This is a quick expansion on domain and range. This is a topic that you guys have heard before. You guys should know what domain and range are, but we are going to take it to a new level here. Past teachers, it could have been myself, could have been other teachers, have probably asked you what domain and range mean, and you guys should have come up with essentially this answer, that you guys know that the domain is the set of all possible inputs, or domain are the x values. That's probably what you guys are familiar with in regards to domain. Similarly, you guys know that the range is the set of all possible outputs, or the y values would also be, is how we say the outputs. However, that's a very simple version of domain and range. We are going to start looking at actually telling me what domain and range are from certain graphs, and that's what I want to cover in this lecture. I do want to say really quickly that domain and range are both now going to be fair game. Anytime I ask you to graph something, just expect that I'm also going to ask for what the domain and range are, and that this information is probably going to be on every test. Every time you graph, which is pretty much going to be every unit, I'm going to ask for, hey, what's the domain and what's the range? So when we first learned to graph, we mostly learned about linear equations. Linear equations are lines, and I want to point out that with these lines, the domain, which is, like we said, is the x values, or what I want to really push you towards thinking about the domain is, what x values does this graph ever achieve? Okay, domain is the set of all x values that our graph ever achieves. And the reason why you guys don't have a very good understanding of domain and range up until this point is because almost all of the graphs that you've done have had the exact same domain and the exact same range, and it was not very interesting or worth actually even thinking about because the domain was always all real numbers. And the range also was always all real numbers. And that's the domain and range for this particular graph. I'm never going to ask you for, I don't usually write the words all real numbers. We do have a mathematical symbol for all real numbers, and that is an R with like an extra vertical line. That's not a very good symbol, a very good version of it, but it's like an R, boom, boom, something like that, whatever. And the range is also all real numbers. Now, would you be able to come up with that? So we're looking at this graph. You guys should know that this graph goes forever this direction, right? Hence the arrow. So what domain is really asking is, what x values does this graph ever achieve? And I think you guys would agree that this graph goes forever to the left, right? It's going down, yes, but it's also forever progressing to the left. And it also goes forever to the right here, right? This graph here goes to the right forever. Yes, it's way up here when it goes to the right, right? It's way up here, but it still achieves every x value to the left and to the right. And so that's why it's all real numbers. Domain is going to work left to right. Similarly, range is going to work downward to upward. So does this graph go forever down? Well, yes, it does, right? Yes, it's going kitty corner or something like that, but it goes down forever. It achieves every y value. It goes to negative infinity down here. And also it goes up forever, right? It achieves 1 here. It achieves 2, the y value of 2 here. 3 here. It goes forever up. Recently in section 2.7, we introduced a different type of graph. It wasn't just linear equations like this. We introduced absolute value equations. And an absolute value equation might look like 2/3 x minus 4 plus 1. And we know how to graph this. We know that this plus 1 at the end is going to shift up 1. The minus 4 inside the absolute value signs here, that's a horizontal shift, and horizontal shifts always happen the opposite way that we think they would. So I would think a minus 4 would shift to the left 4, but it actually shifts to the right 4. So it goes up 1, right 4, and that's our vertex for our absolute value graph. That's where the v's are going to meet. And then the slope from that point is going to be rise 2, run 3, rise 2, run 3, and rise 2, run the other direction 3, giving us this V-shaped graph. Why am I graphing this right now? Well, Absolute value doesn't have a trivial domain and range. And what I mean by trivial is that it's always all real numbers and all real numbers. If we are to look at the domain, domain in the range, one of them is all real numbers and the other one is not. Remember, domain asks what x values does this graph achieve? And this graph goes forever to the left and still goes forever to the right, right? Like this graph is achieving, it's going forever this direction. It's achieving every x value to the right and every x value to the left. So the domain is still all real numbers, but the range is not all real numbers. Work with me here. The range, this graph never achieves any y value of, let's say, -7. This graph comes down here, bounces here, and goes back up. It will never achieve any y value in this vicinity in that circle, right? The y value of -1, the y value of -2, none of those y values are ever achieved. It's going to be imperative that you ask, what is the smallest number of the y values achieved, right? Well, it comes down here and it hits a y value of 1, and it also comes, this direction, and it hits the y value of 1, and it achieves 1, but it never gets below 1. And so the range here, we would say, well, the range is y values greater than or equal to 1. It does achieve 1, and it achieves every y value above 1, but it never achieves anything below 1. Look at a couple examples. This one, we know this is a line. It goes forever to the left and forever to the right, so the domain is all real numbers. Similarly, it goes forever down and forever up, so the range is also all real numbers. What about this graph here? Domain is asking what x values are ever achieved. No x values are ever achieved out here, right? This graph starts existing at -3. Nope. Yep, at -3. And it achieves every x value between -3 and 3, and then stops existing beyond 3. So it only exists in this range. These are the only x values that this graph ever achieves. How do we say between -3 and 3? Hopefully you guys remember how to do your and statements and inequalities. This says that x values exist between 3 and -3, greater than -3 and less than 3. What about the range? Remember, range would be the y values, and I like to start at -infinity. This graph never gets down at never achieves -infinity, right? Never achieves anything up until it starts existing at -4, and it stops, it exists everywhere between -4 and 3, right? This graph exists at -4, exists at -3, and everywhere in between, but stops existing at +3. You'll notice I changed those to or equal to's. It does exist at -3, and it does exist at 3 in the x's, so that's why I changed those to less than or equal to's. Similarly, this graph does achieve -4, and it does achieve +3, so they would be less than or equal to's. What about this graph here? This is kind of a weird one. That doesn't mean we cannot find the domain and range. We still can. The domain. This graph never exists over here at -infinity, right? This is a stop here, and this is a hole. It's to say it doesn't exist at this endpoint. So it doesn't exist anywhere until a -4, right? This graph starts existing at -4, but doesn't actually exist at -4. It just starts just beyond it. So it starts existing at -4, and then it achieves everything beyond that, right? If we're looking at the x's, it goes from -4, not quite, almost there, right? And then it achieves everything towards positive infinity. So the domain here would be x values greater than -4, right? Not or equal to, because it's an open circle. The range would be asking what y values exist. No negative y values exist ever in this graph. The smallest y value that starts existing would be at positive 1. And then it's going to achieve everything above 1, right? Because this graph, this line here, is going up forever. So y values greater than or equal to 1. Here's another example. This one's kind of weird and different than the other examples. Domain and range. This is called a discrete relation, where it's not like the lines are not connected. Therefore, it's not fair to say, hey, everything between -4 and 5 would be achieved, for example. Only these, particular points are achieved. So when you're listing the domain or range, you're just going to list it as a list for this type of function. This graph exists at -3, right, at the x value of -3. This graph exists with an x value of -2. It does not look to exist at -1 or 0, but does exist at the x value of 1 and also exists at the x value of 4. When you look at the range, you're still going to start from the bottom and work your way up. This graph never exists at anything down here in negative infinity or thereabouts. It does exist at -4, a y value of -4, of -2, of 0, 3, and 5. Those are the y values of these points, right? So those are the y values that are achieved by our graph. Last one, this is another absolute value graph. We talked about those at the very beginning. We talked about domain, we talked about range. Domain of this graph, it goes forever to the left and forever to the right. So the domain here would be all reals. In the range here, nothing is existing down here. It's never getting anywhere down here. It starts existing at the y value of -5, and it exists everything above -5. It achieves everything above -5. So this would be y values greater than or equal to -5. Please ask me questions about domain and range. This is going to be a topic that we are going to use all of the time, and it's also a topic that often confuses students. So please do be proactive in asking about this particular topic, and good luck.